Okay. Good morning, everyone. I'm very glad to have the chance to make this presentation here. My name is Jian. I'm from Suzhou University from China. Today, I will share our paper. The title is Exploiting a Sensitive Preference in Deep Cross Networks for Cross-Domain Recommendation. I have divided my presentation into 5 parts. Here is the outline. I'm going to start with the background and the motivation of our work first. Okay, let's get started. Nowadays, we often shopping online in various platforms like Amazon, Taobao, and so on. Product image provide abundant visual information such as design, color scheme, texture, and so on. Researchers have started to use image data for recommendation with various image features, such as CM features, safety feature, and color list. These image features contain semantic information to distinguish items and has been proved effective in recommendation tasks. One important visual fact, aesthetic, has rarely been considered in previous visual content enhanced recommender system. If you know more about your consumer's aesthetic preference, you can recommend the products more convincingly according to consumers' taste. However, few efforts has been found considering the aesthetic preference for recommendation, except they demonstrate that incorporating aesthetic features can improve recommendation preference. However, it does not consider aesthetic features for cross-domain recommendation. Visual aesthetic products plays an important role in decision process when purchasing parent-first products like shoes, hats. Indeed, a user's aesthetic preference, which has served as a personality trait and a basic requirement, is domain independent and could be served as a bridge between domain for knowledge transfer. We think that a user's aesthetic behaviors in different areas has been consistency. This consistency of aesthetic behavior is helpful for cross-domain recommendation, especially when one domain suffers from the data sparsity issue. So we proposed a deep aesthetic cross-domain network, termed as ACDN. Part 2. Our recommendation task is that when you give a user U, we recommend a ranked list of items for each user based on his historic records with the help of the user item interaction information and the user's aesthetic preference from the source domain. Okay, it's a top K recommendation. Part 2, I will introduce the architecture of ACDN. Look at this picture. Our model has 4 layers: input layer, embedding layer, cross-transfer layer, and the last is output layer. Okay, first let me introduce a sensitive network we used. We used an RLG to extract a sensitive preference in our work. RLG is a novel deep convolutional neural network which introduced the inception model into image aesthetic classification and can extract aesthetic features from low level to high level. As shown in the figure, we connect the output of the first incept layer 256 dimension for each, and the last incept layer 512 in dimension to form a 1024 dimension concave layer as a holistic aesthetic features. In our work, for each item in target domain and each item in source domain, we utilize the pre-trained ILG to extract its aesthetic features. Okay, the embedding layer to represent the input, we encode user item into action index by one-hot encoding. For user U item I from the target domain and item J from the source domain, we map them into one-hot encoding, and then we embed one-hot encoding into continuous representation. Finally, we concat the item latent vector, the user latent vector, and the item aesthetic features vector as the input to the next layer. The cross-transfer layer. The core idea of cross-transfer unit is to adopt a transfer matrix rather than a scalar weight to transfer knowledge. The target domain can receive two information flow from the source domain and the target domain. As is shown in the figure, we added cross-transfer unit to the entire base network. We can observe that the representation of each layer receives two information flows. One is from the transform gate controlled by the weight matrix W, and another is from transfer gates controlled by the relation matrix H. This way of knowledge transfer happens in two directions, from the source domain to the target domain and from the target domain to the source domain, which can enable thorough knowledge transfer across domains and let them benefit from each other. And finally, we enforce the L1 normal recognitions on the transfer matrix H to induce disparity. Since we focus on one class and collaborate flirting, the output is the probability that the input pair is a positive interaction. So we use a softmax layer as the output layer. In terms of model learning, according to the task of item recommendation and the nature of the implicit feedback, we adopt cross-interview as our loss function for model optimization, and we add joint loss function to our props model, which can be trained efficiently by backpropagation. And this object function can be optimized by SGD. Okay, part 4 experiments. We studied the effective of our purpose approach on a real-world public dataset measure with different kinds of domains. It contains product reviews and metadata from a measure, which has been used to evaluate the performance of various approach. Here is the statistics of the datasets. Comparison of the performance our model and some baselines. From the two tables, we can find that our method outperforms all baselines. In summary, the comparison results demonstrate that the superiority of our proposed neural model to transfer authentic preference for cross-domain recommendation. To show the advantage of the authentic features, we combine various widely used features in our base model and compare the effect of each type of features by constructing 3 models. And from the two features, we can see that our model ACDN with authentic information performs the best on both datasets. That is to say, a user's authentic preference is domain independent and can be used as a bridge between domains for knowledge transfer. Okay, part 4 conclusion. We are the first to leverage novel authentic preference for cross-domain recommendation by capturing users' domain-independent authentic preference. And we propose a deep cross-recommendation neural network incorporating with authentic preference, which enable direct knowledge transfer across domains by introducing cross-transfer units from one base network to another. And also, we conduct many experiments, the experimental results on 2 large real-world datasets reveal that ACDN outperforms the state-of-the-art methods. Okay, that's all. Thank you.